Alright, welcome everyone. Today we're going to work on unit conversions. The method I'm going to show you is a little bit more long-winded than just moving the decimal, but I guarantee you can use it in any situation to clarify any of your units, and you'll always get the right answer as long as you kind of follow the same method every single time. That's what makes it useful, the fact that you can convert anything, you just have to set it up properly, and that's what we're going to work on. I'm going to try to keep this as short as possible, but we're going to have a lot of examples, maybe half a dozen examples in here. Let's get started. This is the basic unit conversion equation that I use. So the original value, this original value is always going to come from the problem. That is the number that you always start with. It's always the number that's represented in the problem that you're dealing with. The conversion factor, this is the next thing. This is really important because this kind of determines the unit you're going to end up with. And we'll talk about multiple conversion factors in a little bit, but the conversion factor is important. So before we move on, the conversion factors are always equal to 1. Okay, so 1 dozen eggs, for example, is 12 eggs. So if I asked you to go get me 2 dozen eggs, you come back with 24 eggs. It changes the number and it changes the unit, but the representation, the physical representation of what we're talking about is exactly the same, right? Both people, I sent away for 2 dozen eggs, the one I sent away for 24 eggs, they both come back with the same exact thing. And that's what we're going to do here. The number's going to change, the unit is going to change, but it physically represents the same exact thing. That's important. It always has to be multiplied by 1, or the unit always has to be multiplied by 1. So the final part is your new value. The goal is to get to this, obviously, that's the answer, and the new value is always going to essentially have a different number and a different unit, but it should always physically represent the same exact thing as the original number. Okay, so that's the setup every single time. For example, whenever we're doing these, this is always how I set it up. I just pick some random number, let's say 9 grams. Once I get my number out of my equation, this is always how I set things up. There's my 9 grams, that's my original value. Even before reading the rest, set it up like this. Equals, and then something, whatever unit I'm looking for. So times our conversion factor, it's always going to be a ratio, is equal to, and then our new value. We'll deal with that depending on the question. Okay, so let's take a look at a couple examples using this method every single time. Original number times some conversion factor is equal to. Here we go. This just comes from the back of Big Mac. How many Big Macs to reach 2,000 calories? I want to consume 2,000 calories in one sitting. How many Big Macs do I have to eat? Well, what is my original number? My original value is going to be 2,000 calories. That's the number that you get from your problems. 2,000 calories, capital C calories, and then we'll set this up the same way we always do, equals, and there we go. So what is my new value? What do I want that new value to be? How many Big Macs? The number of Big Macs that I'm going to have to consume, that is going to be my answer. Okay, so we want our units to go from calories to Big Macs. That's the next step. We want units to go from calories to Big Macs. That means calories is on the top here, so I need to put it in the bottom on my conversion factor. I want calories to cancel. And then on the top, I want Big Macs because I want that to prevail. I want that to be the result, right? If I multiply calories times Big Macs per calorie, calories cancel, and we should end up with just Big Macs. 2,000 calories is my original number. My conversion factor, I'm going to have to get it from the nutrition facts. Serving size of 1. Okay, so that means 1 Big Mac is worth 572 calories. Okay, so 572 calories, that's going to be my calories. And let's talk about the conversion factor briefly. 1 Big Mac is worth 572 calories. That's it, right? That's the conversion factor. Each of those physically represent the same thing. 1 Big Mac will get you 572 calories. If you want to consume 572 calories, you have to go get yourself 1 Big Mac. Calories are going to cancel. And now we're going to divide 2,000 divided by 572. We find out that and I'll put the number down here. For my calculator, I end up with 3.496. Of course, 3 sig figs here. We need to round to that 9. So 3.50. So 3.5 Big Macs if you want to eat 2,000 calories, okay? But the same setup every single time. Original value multiplied by a conversion factor gives us our new value. So here is another set of examples. This is something more akin to what you're actually going to see in an actual problem. 6 miles into feet. I want to convert 6 miles into feet, and luckily I've got my little conversion factor. So what's my original number? 6 miles. And of course, we always set this up the same way. Times conversion is equal to, and we want our answer to be in feet. There we go. Do I know the conversion from miles to feet? I absolutely do. It's right there in parentheses afterwards. Here we go. We want miles on the bottom because we want that to cancel. We want feet on the top because we want that to prevail. 1 mile is equal to 5,280 feet. Okay, miles cancels. 6 times 5,280 is going to give me 31,680 feet. I'm not going to worry about sig figs, but that's what we end up with. Okay, fantastic. So that's it. Same setup every single time. So I'll give you a second to try this last one before I do it. So let's take a look. 420 lbs. That's my original number times a conversion factor is equal to. Okay, we want our final answer to be in kilograms, so we'll put kilograms over here. I want pounds to cancel, so I'll put that on the bottom. I want kilograms to remain, so I'll put that on the top. All right, 2.20 pounds for every kilogram. Pounds cancel. 420 divided by 2.20 gives me 191 kilograms. There we go, conversion done. Every single time, original number times conversion factor is equal to our new unit. 420 pounds, 191 kilograms, it's the same exact thing. Okay, so make sure you set it up that way every single time and you're not going to run into a problem. The next step, the multiple conversions. Sometimes we're not going to know the direct conversion. So if I give you, for this, for example, how many seconds in a year? Can you tell me how many seconds are actually in a year without kind of doing some math in your head? No way. Well, if you know that, congratulations. But seconds in a year, we don't know that. So what we're going to do instead is we're going to use multiple conversion factors. This is going to feel like it's somewhat long-winded, but the end result is we're going to get to our answer. So let me just put these out. There we go. How many seconds in a year? What is my original number? Well, a year, right? So just 1 year, that's my original number. I might need extra room to do this, so make sure you give yourself plenty. 1 year times a conversion factor. And do we know the direct conversion from years to seconds? We don't. What do we know? Well, I know how many days are in a year, right? Year, we want to get rid of years because we want to move away from it. And we'll put days on the top. 1 year is equal to 365 days. Fantastic. That's a good start. Years is going to cancel. We're going to be left with days. Do I know how many seconds in a day? Not really. So let's set up another conversion factor. I want days to cancel. And what do we know? Well, hours in a day, right? So what do we know? There are 24 hours in 1 day. Fantastic. Let's keep moving. So that's going to leave us with hours. We want hours to cancel. We'll put that on the bottom. We know how many minutes in an hour. There are 60 minutes in 1 hour. And then finally, minutes to seconds. Minutes are going to cancel. There are 60 seconds in 1 minute. And that should leave us with seconds. Let's check. Year, year, day, day, hour, hour, minute, minute, and that's going to leave us with seconds. So if we multiply that all out, 1 times 365 times 24 times 60 times 60, what we find out was 31,536,000 seconds. Okay, so very long, I recognize, but that's the idea. We want to keep working our way through until we recognize we know a conversion to get to. In this case, we had to get all the way down to minutes before we could get to seconds. multiple conversions. You can keep converting it until you end up with your answer. That's it. That's how we do multiple conversions. This next slide here. I love to do this in my class, and it's somewhat humbling, I'm sure. If a student pays $50,000 per year at university, if a student takes 5 classes per semester, how much does each session, so each time you walk into a class, Monday, Wednesday, Friday, how much does it cost for a 14-week semester? Let's start with this. What is my original number? $50,000 per year, okay? That's my original number, $50,000 per year. What are we changing here? We're not changing dollars because we want the final unit to be in dollars per session. So actually we're changing the lower one this time. What we want to cancel is I want year to cancel. So if we want year to cancel, what do we know about year? Well, semester. We have 2 semesters per year for a typical student. That's going to allow years to cancel, and that's going to give us semesters. Next conversion, because we want to work our way through until we're in dollars per session, right? We want semester on the top because we want that to cancel. What do we know? Classes, right? How many classes are we taking per semester? One semester we're taking 5 classes, at least according to our problem here. Semester cancels. Next up, we want classes to cancel, and we're going to put weeks on the bottom because there are 14 weeks for each one class. Classes cancel. So this is going to be dollars per week. We could stop there and we'd end up with our units would be dollars per week if you want to know how much you're spending per week. And one more time, we want week to cancel, and we're going to put that over sessions. So for the typical Monday, Wednesday, Friday class, we have 3 sessions per week. Okay? What does that leave us with? Well, weeks cancel, and we're left with 50,000 divided by 2, divided by 5, divided by 14, divided by 3. The number that you actually end up with is equal to $119. It's a terrible writing, but that's fine. Dollars per session. So this means for every time you miss class, you're basically paying $120, assuming you pay $50,000 per year. I encourage you to put your own number in there. Instead of $50,000, what do you pay to go to school for a year? How long is your semester? How much do you pay per class session? It's somewhat jarring, so make sure you go to class. All right, so that's multiple conversions. You can just basically keep running through the units until you end up with, well, your answer. All right. That brings us finally to what we're looking for, the metric system. We've seen it a couple times. I haven't really mentioned it. First of all, the U.S. system, we use miles, we use feet, inches. It's kind of a nightmare in terms of conversions because it's not really round, right? 1 mile and 5,280 feet. Not super easy in terms of moving the decimal or kind of nice even numbers. The SI unit, the metric system, what most people use, it's by factors of 10. 1 kilogram, kilo, we've got this little prefix. Okay, I don't need to go through all of this, but the kilo represents essentially 1,000 times the base unit, which would be gram. 1 meter is equal to 100 centimeters. Okay, centi meaning 100, milli meaning 1,000. So these prefixes essentially tell you what factor of 10 you have to multiply your units by. Okay, if you want to learn more about the metric system, I encourage you, and it's really important to understand, especially in science. Here is our metric system prefixes. Here's a prefix, and here is a multiplier. This is what they do to your numbers, right? A kilo is 1,000 times greater than just a regular unit. Meter, liter, all the base units for the metric system. Okay, it's important. It's very important that you understand that moving forward. Those base units are what we start with. So, what's next? So let's use these prefixes in order to do conversions, and we're still going to set it up the same exact way. Convert 23.4 grams to kilograms. It's 23.4 grams. There's my original number times a conversion factor is equal to, and we want to end up in kilograms. Do I know grams directly to kilograms? Absolutely I do. I can look on my little table. I can see grams directly to kilograms. So I'll put grams in the bottom. I want that to cancel. Kilograms on the top. I want that to prevail. And I always tell my students to do this. Which of these two is bigger, a kilogram or a gram? Kilogram is, so we're going to set it to 1. How many grams go into 1 kilogram? 1,000. You can use the numbers directly from the chart. I found it's easier to do it this way for students because then you're not using any decimals. They're all going to be above 1 or above, and it's going to make life just a little bit simpler. Grams cancel, and we're left with kilograms. So 23.4 divided by 1,000 is going to be 0.0234 kilograms. There's my answer. Okay, next up, convert 45 centimeters into meters, so we'll set it up as we do, equals meters. Okay, same exact setup as normal. We want centimeters to cancel, throw that in the bottom. I want meters to prevail, I'll put that on the top. Which of these two is bigger? 1 meter is bigger. 1 meter is going to equal 100 centimeters. Centimeters cancel. We end up with 0.45 meters. Okay, I'm just doing the math. There we go. Those are single conversions. Very easy. If you know the conversion, it makes life really simple. Multiple conversions. So now, do you know conversion from centimeters to kilometers? Most people don't. It's a matter of moving the decimals, but once again, we're just going to use our method because it's going to be simple. We're going to use the original value, original number, okay, multiplied by conversion factor 1 times conversion factor 2, so on and so on until we get to our answer. Okay, we'll start with our original number, 200 centimeters, multiplied by conversion factor. Generally what you do is you go to the base unit. Okay, so centimeters, I don't know centimeters to kilometers, but I do know centimeters to meters. We want centimeters to cancel, so we'll put that on the bottom. 1 meter is a meter is bigger than a centimeter to 100. Centimeters cancels, and we're going to be left with meters. Of course, that's not the answer we want. We're looking for kilometers. Do I know meters to kilometers? I absolutely do. Meters on the bottom, kilometers on the top. Okay, 1 kilometer is equal to 1,000. There we go, 1,000 meters. Meters cancel, and we should end up with our answer. So it's going to be 0.002 kilometers. You can check it if you want to, but it's right. There we go. Same thing down here. Now we're going from milligrams to centigrams. So we are small and small. We're actually not going through a gram. Okay, so 32 milligrams times some conversion factor. In this case, once again, we're going to go through our base unit. We want milligrams to cancel. We're going to get to grams, because once we get to grams, we can go back to what we need to. 1 gram is 1,000 milligrams. Another conversion. I want grams to cancel this time, and I want to be left with centigrams. 1 gram is equal to 100 centigrams. Milligrams cancels. Grams cancel. And I am going to be left with 3.2 centigrams. That's the unit I have left. Okay, so that's it. Multiple conversions, we just have to know the direct conversion. If you go to the base unit first, that should always be, if I don't know directly, if it's not to the base unit, go to the base unit and then proceed from there. Prefixes are hugely important. You can absolutely move the decimal, but we'll always get it right this way. That's what I tell my students. You will always get it right this way. Okay, I hope that helped. I hope it wasn't too long. I'll give you these to do if you want to leave your answers in the comments, and people will comment to make sure they're all right. I would appreciate it. I hope this helped. Good luck, and I'll be creating more videos soon. All right, bye now.